Hi everyone, today we are going to learn subtopic liquid. Learning outcome for subtopic liquid are: A. Relate the properties of liquid to intermolecular forces, molecular arrangement and molecular motion in explaining shape, volume, surface tension, viscosity, compressibility and diffusion. B. Explain vaporization and condensation processes based on kinetic molecular theory and intermolecular forces. C. Define vapor pressure and boiling point. D. Explain boiling process. We have 5 properties of liquid: shape and volume, compressibility, surface tension, viscosity, diffusion. For shape and volume, a liquid flows to fit the shape of its container and is confined to a certain volume, has a definite volume but not have a definite shape. In terms of molecular energy and molecular motion, the molecules are arranged closely packed together but not rigidly, held together by strong intermolecular forces but not strong enough to hold the molecule firmly or in a definite shape. Molecules able to move freely. For compressibility, compressibility is a measure of the ability of a substance to be forced into a smaller volume. More difficult to compress than gas, the little space between liquid particles limited ability of liquid to be compressed, hence it has low compressibility. In terms of molecular energy and molecular motion, in liquid, the molecules are packed closely together but not in orderly arrangement. So, there is very few empty space between liquid molecules. Liquids are much more difficult to compress than gas. For surface tension is the amount of energy required to stretch the surface of a liquid by a unit area. The liquid has surface tension cause the liquid surface to tighten like an elastic film. The surface tension decreases with increase in temperature as the difference in intermolecular forces become less significant when the molecules move faster. In terms of molecular energy and molecular motion, molecules within the liquid experience intermolecular attractive forces in all directions by their neighboring molecules. Molecules at the surface experience intermolecular attractive forces downward and sideways by neighboring molecules but not upward away from surface. Molecules at the surface are attracted inward and cause the surface to strengthen and tighten. The stronger the intermolecular forces, the higher surface tension. Diffusion. The rate of diffusion of liquid is slower than of gas. Occurs when a molecule is able to free from the attractive forces with neighboring particles that surround it and move to another region. In terms of molecular energy and molecular motion, in liquid, the molecules are packed closely together but not in orderly arrangement. The liquid molecule cannot move freely from one part of a liquid to another. There is stronger attractive forces between liquid molecules and restrict their movement. So the diffusion rate of liquid is lower than gases. Viscosity. Viscosity is a measure of a fluid resistant to flow. Viscosity decreases as temperature increases. In terms of molecular energy and molecular motion, the stronger the intermolecular forces between molecules, the slower the rate of fluid to flow. Viscosity is higher. At higher temperature, the cohesive forces are offset by molecules with higher kinetic energy, so reduce the viscosity of liquid. The rate of fluid to flow becomes faster. Vaporization is process when the molecule changing from liquid to a vapor. Vaporization we can divide by boiling and evaporation. Evaporation occurs at any temperature and pressure occur on the surface of a liquid. Vaporization in terms of kinetic theory and intermolecular forces. In liquid, the molecules are packed closely together but not in orderly arrangement. They are in rapid motion and collide with each other. When the temperature is higher, the average kinetic energy of molecule increases and their molecule motion also increases. If the liquid molecules at the surface possess sufficient energy to overcome the attractive forces with neighboring molecules, they escape as a gas or vapor. The stronger the intermolecular forces, the lower the rate of vaporization. Condensation is processed when the molecule changing from vapor to a liquid molecule, the reverse of vaporization. In terms of kinetic molecular theory and intermolecular forces, in gas, the molecules are apart and in random motion and collide with each other, wall of container or the surface of the liquid. When the temperature is lower, the average kinetic energy of molecule decreases and their molecule motion also decreases. Gas molecule cannot remain as a gas as they reach the surface of liquid. If the gas molecule cannot overcome the attractive forces by liquid molecule, they will return as liquid molecule. This diagram shows the vaporization and condensation process. Arrow for blue area show molecule having high kinetic energy can overcome the attractive forces and vaporization, whereas for area yellow show a vapor pressure exerted by molecule on the surface of the liquid. In between yellow area and blue area to show a molecule may lose its energy during collision and get trapped among the liquid molecule, leading to condensation. Vapor pressure. Vapor pressure is the pressure exerted by vapor molecule while in the state of dynamic equilibrium with its liquid. Dynamic equilibrium, that means rate of forward reaction, is exactly equal to the rate of the reverse reaction, or rate of evaporation and condensation are equal. This diagram shows the dynamic equilibrium, where the rate of vaporization and the rate of condensation are equal in number of molecules leaving the liquid surface in the same as the number of vapor molecules entering the liquid state. Boiling point. Boiling point of a liquid is defined as the temperature at which its vapor pressure equals the external pressure. The normal boiling point is the temperature at which the vapor pressure of the liquid is equal to 1 atm. Okay guys, that's all.